everyone, and welcome to day one of integrals. We are done with derivatives. You won't see it again until that's not true. We will keep seeing derivatives, but for this unit, we will not be looking at them as much. We're working backwards now. So we're going to basically learn how to find integrals this unit, and then we're going to learn about the applications afterwards. But we're going to get just get it done and out of the way of learning how to find them. So if we think about this, if we start with the derivative of the derivative equals x cubed plus 3, what was the original function? Well, if I know that I need to get x squared, the derivative rule states that if I have x to some power, I bring it out in front and subtract 1. So if I bring this out in front and subtract 1, what did the original exponent have to be? Well, if I subtracted 1 to get the derivative, I know that the original function had to be an x cubed. If I bring that 3 out in front, I know that I need to then divide by 3 since I don't have a coefficient here. So if I bring this 3 out, then it cancels with that 3. So we're going to have x cubed over 3 plus, and then if it's a 3, I know that there is an x that had to be with it, so 3x, plus a number that might have been here, because then the derivative of any number goes away. So again, so it's not crooked. X cubed over 3 plus 3x plus what we're going to call a constant. This is just a number. We don't know what that is. A function f is called an antiderivative of a function if f equals the big F prime of x equals little f of x. And the rule that we're going to use here states that the integral of x to the n equals x to the n plus 1. It's the opposite, so of course we're going to plus 1. We would have brought this out in front. That's multiplication. The opposite of that is division. So divide by n plus 1. Then you need this plus c. This plus c is a constant that we don't know what it is. And at the end of the notes we'll look at that, of how to find it. So the power rule, x to the n plus 1 divided by n plus 1, all added to a plus c. This dx right here tells us what we are taking the integral with respect to. The same idea when you did d over dx, this is taking the integral of that. So the very first example equals x cubed, add 1, divide by the n plus 1, 2 plus 1 is 3, plus c. For the next one, this 3 can come out in front, so we could rewrite it as 3 of the integral of x to the 4th dx. All that does is a constant. It's the same thing as derivative. So we're going to say it's 3 times x to the 5th divided by 5. Why? We add 1 and divide by what we added to 1 by plus c. So we rewrite that as 3/5 x to the 5th plus c. So what I want you guys to do is pause it and do the next 4 problems. Yes, we will have to distribute. Yes, you're going to have to convert square roots into radicals. Okay, but let's try those next 4 problems. When you're done, click it back on. So just take a minute and look. See what you got right, see what you got wrong. See if there's anything that you have questions on. We did bring the x squared back in the denominator here. With this 3 halves, 3 halves can be rewritten as the power x cubed in the square root. This 2 is square root. So hopefully that you got all those right. Pause it if you need to, and then we'll go to the next page. This one looks like a pain. Well, we can think of it a couple ways. One, we could take the integral of each of, well, that's how we're going to do it, of each of them separately. And so when you take the integral of each of them separately, know that in class you do not need to write that out, okay? That this is not needed to write out. You can just do this in your head. But the integral of x to the 5 halves is 2/3 times, add 1. The 2 right here tells you how much you're adding, so x to the 7 halves, divided by 7 halves, minus 6 times, so again, tell you what you're adding. So if we're adding 1, we're adding another 4/4, so x to the 7/4 over 7/4 plus 2. Adding 1 to a negative 1/2 gives you a positive 1/2 minus the integral of any constant. We're just going to add an x onto it, so 7x plus c. So our final answer, we're going to multiply by the reciprocal, so we're going to get 4 over 21 x to the 7 halves minus 24 over 7 x to the 7 fourths plus 4 x to the 1 half minus 7x plus c. Make sure I did that right, looking at my answer key. And nope, again, I made this mistake last year too. 4/3 right there. So it's really multiplying by 7/3. So the 3 goes there, so this is 21. My fault. And you can rewrite this. I could have rewritten this and know that you don't have to, but could have rewritten them as radicals. Why don't you guys try this one? This one you're going to have to double distribute. This 4 can be brought out in front, so just double distribute that and go for it. So double distributed, took the integral of the inside, then multiplied by 4. 12 divided by 2, 6 times 4. Oops, and you need a plus c at the end. If we scroll down, we're going to get to the next examples, which are important examples. If I rewrite 1 over x as x to the negative 1, and I try to take the integral of x to the negative 1, you're going to realize I'm going to get x to the 0 over 0 plus c. And we know that that cannot happen. Cannot divide anything by 0, and so this is not good. The thing that you need to realize is you're going to go back and say, well, what, when I take the derivative of something, gives me 1 over x? And you're going to realize that it's the natural log. It's the natural log of the absolute value of x plus c. Important to remember the absolute value there. So the integral of 1 over x is the absolute value, the natural log of the absolute value of x. Just important, you can never take the integral of 1 over of x to the negative 1. It just won't work, but we know that the natural log will give us, the derivative of the natural log will give us 1 over x. Same idea here, we can bring the 4 out, e to the x dx. Well, what's the integral of e to the x? It's just e to the x. So we're going to get 4 e to the x plus c. For this next example, the one thing that you are going to want to realize is that we're going to take the, we could rewrite it as all out of each term. We're just going to take each term and divide it by x squared. So now that I can't read that, 3x to the 5th minus 4x to the 4th plus 7x plus 6x to the negative 2 dx for all of that. And now you're going to just take the integral. So why don't you guys try that? And hopefully you ended with that answer. Take a minute to look at it. The final part of the notes is looking at integration. And you're going to have to just think in the reverse way. I don't have a good way for you to remember all of these except for the fact that since it's integration, it's backwards. If you do not see a c, you make it negative. If you do see a c, you do not change the sign. It's only for derivatives. Key ones here is this one. The integral of secant x tan x was just secant x. And people forget that one. Secant squared x. We know that if you take the derivative of tangent, you get secant squared, so it's the same, it's the opposite here. So if we look at the first one, again, we can bring that 7 out in front. 7, integral of cosine x dx. I put this on there because it is not, the sign does not change. 7 sine x plus c. The integral of cosine x does not change signs. It just becomes sine x. For this one, you're going to see that's 1 over cosine squared theta. You have to know your reciprocal trig functions. You get the integral of secant squared theta d theta. And now we know, I just talked about that, what the integral of secant squared theta is. We know it's tangent. But you've got to know that 1 over cosine is secant. 1 over sine is cosecant. This next one, and the last one that we will do, is sine over cosine squared theta. Well, I just talked about that. Does it help for us to rewrite it as sine theta times secant squared theta? So you go and look at your chart and you don't see anything with sine theta, secant theta here, so you're like, oh, okay, well, nope, that doesn't work, so cross that off. How else can we rewrite this? Well, we could rewrite it as the integral of sine theta over, just do 1 cosine theta times 1 over cosine theta. And so with this, well, we can then rewrite these. We know that sine over cosine is tan. We know that 1 over cosine is secant. We know what secant tan theta is, the integral of that. We know that that's just secant theta. There's another one that I start. And so if we took the integral of that, then I can just say that that's secant theta plus c. And this is where people have trouble of rearranging. Another way that we could rearrange this is that the integral of sine theta times 1 over cosine theta times 1 over cosine theta. It's the same thing. Don't forget that. And then I could see that sine theta and cosine theta could go together to make tangent, and that that's secant square or secant theta. So another way to do that, it doesn't matter to me if you saw it in the red way here or the blue way there. It doesn't matter. It's just as long as you can see that you have to rearrange in that numerator and denominator. On to the final portion of the notes. This is where you're going to solve for c. So notice that this is called the initial condition. And so the initial condition is going to tell us how to solve for c. This is not difficult to find. That's equal to x cubed over 3 plus 6x plus c. But we've got to solve for c. Well, this is our x, that's our y, and so we're going to solve for c by plugging in. We know that this is y. Excuse me for not having y equals there. The original function gives us y. So we're going to be able to plug in y. 3 equals 4 cubed over 3 plus 6 times 4 plus c. And I can solve for c now. 3 equals 64 thirds plus 24 plus c. And so c is going to equal negative 127, trust me on that, over 3. So our final answer, y equals x cubed over 3 plus 6x minus 127 over 3. Done. Solving for c is the key here. And so we're on to the last problem now. We've got find the original function when the integral of sine x dx, and we have the initial condition of 0, 1. So we're going to take the integral of sine x. Remember that it's the opposite, and therefore we're going to have to change the sign here. So this is going to be y equals negative cosine x dx. And now we're going to, sorry, not dx. I don't know what I was thinking there. Negative cosine x plus c. Can't forget the plus c. We're going to plug in now. So 1 equals negative cosine of 0 plus c. Go over here. Cosine of 0 is there. Cosine is the x value. And so we're going to get 1. So 1 equals negative 1 plus c. And so c equals 2. And so the original function is going to be y equals negative cosine x plus 2. Please review any problems you did not understand and ask them in class when I see you in class. Have a good day.